Okay, my dear students of grade 9, today we are going to continue force, and today is a special case because I was taking your class. I was recording just like before, just writing and explaining, and I was recording, and when I was just about to finish, my camera froze, and when I have to restart my phone and all the recordings are lost, so I have to record it again. So see, I've already written everything while I was taking your first class. So today I'm just this time I'm just going to explain. Okay, I'm not writing. If you need to take note, then you can always pause the screen. Pause the screen and copy it down. Okay, today we're going to continue momentum and Newton's second law of motion. Last time we discussed about Newton's first law of motion. Okay, let's start from momentum. Actually, momentum is the function of mass of an object and its velocity. Okay, let's say I have an object here. Okay, whatever this is. Suppose this is a bus. Yes, this is a bus. Okay, it's not moving at all. Means, does it have any force? Okay, in general we ask like that, does it have any force? No, but when it moves, it definitely has a force, because as here is building. Suppose here is a building. If the bus, okay, here's an object, if the moving bus strikes, then either the object collapses or it gets displaced. That means it has force. Yes, so when it is not in motion, it does not have any force. Or let's take another example. Let me take another common object here. What I have, let me see. Okay, I have an eraser. Suppose this is a truck, loaded truck, and this is a simple car. Okay, and if both of them are moving with same speed, tell me which one will have more force? Obviously, you all know that the truck will have more force and the car will have less force, isn't it? Or if two cars are moving but with different speed, then obviously the car with highest velocity, highest speed will have more force. Okay. Up until now, in what case we are saying force? They are not actually force. Actually, they are momentum. Okay, if a car is moving, it has something, but that is not force, that is momentum. If the car is not moving, there is no momentum. If the car is moving, there is momentum. So momentum is the property, momentum is the phenomenon or property which is possessed by an object because of its mass and its velocity. So momentum is the function of mass of an object and its velocity. Okay, if an object does not have mass, then it does not have any momentum. But if an object has mass and yet it's not moving, then also it has no momentum. Okay, for momentum to be possessed, it must have mass and it must be moving. Okay, now in most of the cases we confuse momentum with force. Okay, just like I told you, when an object is moving, we usually consider that the object has some force, but that's wrong. The object has some momentum. But when this object having momentum collides with another object and it causes movement of another object, then its momentum is transferred to this next object. Okay, so its momentum decreases while its momentum increases. So in that case, when it collides and comes into action, at that moment it is called force. Okay, got it? Force for this object. This object is providing force to this object because the momentum of this object is actually an external agent for this object. Are you getting or not? I guess if you're confused, once again, let's say let me take camera a little bit up, further up. Let's say this is an object in state of rest. Okay, let me move this out. This is an object at state of rest, yes, and this is moving car. Okay, the moving car has momentum. It does not have force. Don't be confused. We tend to say that it has force, but it does not have force. What it has? it has momentum, but because that is its internal property. Okay, and we define force as external agent, that property which it has in it because of its mass and its speed, that is called momentum. But when it strikes another object and causes that another object to move, in that case this momentum of this object becomes force for this object. Okay, so when momentum comes into action, it becomes force. Okay, so it is like water in dam and flowing water. Okay, see, when water is in dam, okay, water is stored in dam, it is not moving, and that is considered as to have potential energy. But when the dam is released, water start to flow. Okay, and then it possesses another form of energy, it starts to do work, that is kinetic energy. Okay, so that is the difference between momentum and force. So you can say momentum is the cause of force. Okay, it is because of momentum, it is momentum that another object experience force. Understand? Okay, so here I've written the mathematical expression where P equals to m into V. P means momentum. Momentum equals to mass into volume. And first example, I considered an object, a cricket ball, whose mass is 100 gram, that is 0.1 kg. In first case, the cricket ball is thrown with 2 meter per second speed. In second case, it is thrown with 20 meter per second speed. That means it has the momentum of only 0.2 kg meter per second. Mass 0.1, velocity 2, 0.2 kg meter per second. But this cricket ball in second case, it has more momentum of 2 kg meter per second. Mass 0.1, velocity 20. Now, obviously, if you hit me with a ball slowly, then I do not get hurt much more. But if you hit me with much more faster, then obviously I might get hurt, isn't it? That means this case the ball has more momentum. Why does it have more momentum? Because it has more velocity than case 1. And I took another example of a car and a truck, loaded truck. Okay, let's say the weight of a car is only 300 kg, but weight of the truck is about 1500 kg, and both of them are moving with same speed, 5 meter per second. Okay, once again, which one will have more force? Now I will not call it force. I already told you I will not call it force. What is it? It is momentum. Which one has more momentum? Definitely, for the car, the momentum is mass 300 kg and speed 5 meter per second. That means 1500 kg meter per second. And for truck, mass 1500 kg and speed 5 means it has 4500 kg meter per second. So the truck has 3 times as much momentum than the car. Okay, so here keeping the speed constant, momentum depends on mass. Here keeping the mass constant, momentum depends on speed. So momentum is the function of mass and speed or velocity. Okay, now let's go to defining force. Previously we defined force as the external agent which changes or tend to change state of an object from rest to motion or motion to rest. Now in terms of momentum in physics, definition of force in terms of momentum is more acceptable than the classical one. In terms of momentum, force is defined as change in momentum per unit time. Okay, now let's say this object, okay, let me zoom it down. Okay, this object is initially at rest. That means its speed is 0 meter per second and its mass is 200 kg. Okay, so it does not have any momentum. Initially it has momentum 0 kg meter per second. Not moving, no momentum. Okay, it's like no work, no money, no income, just like that. Okay, then another object impacts on this. Yes, and to impact on this car, that another object has to move, and that another object must have some mass. That is, this object has momentum. Okay, and when that object hits the car with some momentum, then momentum of this car becomes force for this car, or that means momentum of this car decreases whereas momentum of this car increases. Okay, and the rate of increase in momentum or amount of momentum of this car is equals to amount of momentum decreased in this car. Okay, change in momentum will be same. That is, force applied by this car on this car will be equal to force received by this car. Okay, now but due to collision, right when there is collision, this momentum is now called force. Okay, due to collision the car moves, and in 1 second time its velocity reaches 2 meter per second. That means after 1 second its momentum becomes 400 kg meter per second. Okay, mass 200 kg and velocity 2 meter per second. So its momentum changed from 0 kg per meter per second to 400 kg meter per second in 1 second, and that is called force. So its force is 400 kg meter per second square, and this is, this is a component of Newton. So force equals to 400 Newton. So from this example it becomes clear that force is defined as the change in momentum per unit time. In 1 second time, how much momentum is changed, that is called force. If you apply more force here, maybe its velocity will rise to 4 meter per second and its final momentum would be 800 kg meter per second and force would be 800 Newton. It goes like that. Yes. So according to this definition, force is calculated by final momentum minus initial momentum divided by time. And final momentum, momentum means mass into velocity, and since final velocity is indicated by v, its final momentum would be m into v, and we have placed here p2, or final momentum, equals to m into v. And initial momentum, since its initial velocity is indicated by u, initial momentum would be m into u, that we have placed here, m into u, and t is here. And then I took common, m is taken as common, then I get v minus u by t, and v minus u by t is an expression for acceleration, so it becomes f equals to m into a, and this is the formula we are going to use in our numerical section, or you can use this formula as well. Okay, or f equals to mv minus mu by t. You can use this formula as well, or direct you can use this formula as well. Whichever step you can use it doesn't matter. Now based on this formula, Newton's second law of motion has been derived. Okay, some many claims say that this formula is derived from Newton's second law of motion. Many claims it, but I say Newton's second law of motion is actually derived from this formula, because I have seen some analysis or some paper, internationally published paper, which does not derive Newton's second law of motion from this equation, but from this equation. Okay, and in those papers Newton's second law of motion is derived from here, or you can say from here, from the definition of force, not from here. Okay, so I'd say Newton's second law of motion, we are going to define it, but before defining it we have to start from here. It gives you the concept. Okay, and you can make the definition on your own, we can make this statement on your own. From f equals to ma, we need to isolate acceleration. Okay, we need to isolate the term acceleration. By isolating a and cross multiplying m, you get a equals to f upon m. If you keep f as constant, then you get a is proportional to 1 upon m. That means suppose you have a car and a truck. Car has less mass, truck has more mass. Okay, and we are keeping force constant. Okay, if you apply same amount of force, then what happens? With the same amount of force, say a car gains the velocity of 40 km per hour in 1 minute, whereas the truck requires 5 minutes to reach the same velocity, applying same amount of force. Okay, that means if there is less mass, if an object has less mass, then it gains acceleration faster than the object having more mass, applying same amount of force. So a is proportional to 1 upon m, and this is the first expression. And in another case, if you keep mass as constant, okay, if you keep mass as constant, then you get a is proportional to f, hence a is proportional to f when m is constant. So to look at this example, suppose you have the same car. Okay, if you apply less force in first case and more force in second case, what happens? The car will gain its acceleration more slowly. Yes, but if you apply more force, the car will accelerate faster. Yes, that means A is proportional to F. So it gives us two conditions. Yes, two statement. If F is constant, A is proportional to 1 upon M. If M is constant, A is proportional to F. Okay, so these two equations are actually the statement of Newton's second law of motion. The Newton's second law of motion states that acceleration produced in a body, see, acceleration A, yes, A means acceleration produced in a body is firstly directly proportional to force applied on it. This one, if you apply more force on an object, then it accelerates faster. And secondly, inversely proportional to mass of it. Yes, if the object has more mass, then there will be less acceleration. Okay, so this is a statement of Newton's second law of motion. Actually, you can, if you forget it, you can make it on your own. Okay, from these two statements. If you forget these two statements, you can always begin from here. Okay, now let's go to theoretical verification of Newton's second law of motion. Okay, let us suppose an object having mass m is moving at initial velocity of u and it gets final velocity v in time t. So this is an object, it's moving with velocity u. If you do not apply any force, it will keep on moving at the same speed, same velocity. But if you apply some force, then its velocity will increase. Okay, and after time t, its velocity becomes v, and its final velocity. So according to definition of force, we know force equals to change in momentum by time. Okay, change in momentum means final momentum minus initial momentum by time. Now final momentum is, as I already told you, m into v, minus initial momentum is m into u. M is taken common, it becomes v minus u by t, and you know that v minus u by t means acceleration from the definition of acceleration. Okay, so it becomes F equals to m into a, and isolating a, you get a equals F upon m, and if you keep F constant, you get a is proportional to m. If you keep m constant, you get a is proportional to F. Okay, so this is the verification of Newton's second law of motion, isn't it? Okay, Newton's second law of motion states exactly the same thing. Okay, now if you are asked to theoretically verify Newton's second law of motion, you always give this procedure. Okay, pause the screen if you need to copy, pause the screen and then copy it. Okay, now let's go to the next topic. Okay, when I go through many of the textbook, what I see that they use another procedure. They actually say verification of Newton's second law of motion. Verification of Newton's second law of motion. Okay, I'm not going to tell which book is it. Okay, but I'm showing only this much. Okay, it says explanation or verification of Newton's second law of motion. But to explain Newton's second law of motion, it is using Newton's second law of motion. Where is the logic in that? Okay, there is no logic. To explain Newton's second law of motion, you cannot simply use Newton's second law of motion. Okay, that's why this is actually not explanation of second law of motion. This is actually derivation of relationship between force, mass and acceleration according to Newton's second law of motion. The title is misleading. This is not explanation. This is derivation of relationship between force, mass and acceleration. Okay, so I'm going to go to the next title, derivation of relationship between force, mass and acceleration. Don't be confused. Your book claims it to be verification. Maybe other teachers also do so. Okay, they also prefer this way to do it. When I was student, my teacher also used the same method. Okay, this same method they also used, not just in school but in college also they used this same method. But when I try to go through international papers, I indeed found that most of them used definition of force. They use definition of force to verify Newton's second law of motion. Okay, anyway, I'm going through it. but in the title, not of verification but of derivation. Okay, derivation of relationship between force, mass and acceleration. Now let us consider a body of mass m produces an acceleration a when the force is applied on it, and according to Newton's second law of motion, acceleration produced in a body is directly proportional to the force applied. If you remember from statement of Newton's second law of motion, these two are the statement of Newton's second law of motion. Yes, it says acceleration produced in a body is directly proportional to force applied and inversely proportional to the mass, isn't it? So A is proportional to F and A is proportional to 1 upon m. Now combining these two equations, you get A is proportional to F upon m. And by cross multiplying, you get F is proportional to m into A. And in physics, by removing proportionality sign, you can always put constant term to remove proportionality sign. Yes, and in this case, this proportionality term, to define this proportionality term, Newton defined 1 Newton force. Okay, he defined 1 Newton force, and he defined 1 Newton force being 1 meter per second square acceleration produced in a body having 1 kg mass. Okay, that means suppose you are given an object having 1 kg mass. Yes, if you do not apply any amount of force, then it does not move. But by applying how much force? By applying how much force, it moves exactly 1 meter distance in exactly 1 second time. Okay, by applying how much force on 1 kg object, it moves exactly 1 meter distance in 1 second time. That much force is called 1 Newton force. That means, see, its mass is 1 kg and its initial velocity is 0 meter per second and final velocity is 1 meter per second. Okay, so its acceleration, its velocity changes by 1 meter per second in 1 second, so it becomes 1 meter per second square acceleration. Okay, so according to this definition, acceleration 1 Newton force being 1 meter 1 Newton force. Okay, Newton defined 1 Newton force being 1 meter per second square acceleration produced in a body having 1 kg mass. You might be asked, what do you mean by 1 Newton force as well? So take it out. That means force equals to 1 Newton when mass equals to 1 kg and acceleration equals to 1 meter per second square. And substituting these values, we get F equals to K into M into A. F equals to 1 Newton, M 1 kg, A equals to 1 meter per second square. Yes, and you know Newton comprises of Newton equals to kg meter per second square, that we have discussed in first lesson. So these units are all cancelled and you get k equals to 1, and substituting that value in equation number 3, you get F equals to 1 into ma. That means F equals to ma. So it is proved. Okay. Now let's go to next topic. Let's say next question. Okay, this is a common question. Why does a cricketer moves his hand backward while catching a ball? You know, a ball is someone throws a ball, you catch the ball, but if you immediately stop the ball, then it will hurt your hand too much. What you have to do after catching the ball, you have to move your hand backward. Okay, like that. Let me like this. Okay. Where is my erase? Okay, suppose this is a ball, the ball is coming. Okay, you catch the ball and then you immediately stop, then it causes pain a lot. But if the cricketer do what? The ball comes, you catch the ball, but right after catching, you move the hand backward. Yes, like this. Okay, so if you play cricket, you know what I'm talking about. Why is that? That will reduce the pain. Now, what is the theoretical reason behind that? See, solution. We know F equals m into v minus m into u by t. That means final momentum minus initial momentum. And mv minus mu is change in momentum. So initially the ball hits you with certain speed. That is, the ball has certain momentum. And finally the ball has to stop. That is, its final velocity is 0 and final momentum would be 0. So there is change in momentum. Okay, but it takes some time. Yes, how much time does it take for the ball to stop? After striking your hand, not after throwing the ball, but after striking your hand, how much time does it take to stop? That is called t, or time of impact. Okay, after the ball strikes your hand, right when it touches your hand, right from that moment, how much time does it take to stop? That is known as time of impact. So F is inversely proportional to T. Okay, if the change in momentum is kept constant, F is proportional to 1 upon T. That means by increasing time, you can reduce force. Okay, by decreasing time, you can increase force. That's why by lowering the hand or moving hand backward, time of impact is increased. It reduces force exerted by the ball on the hand of cricketer. So the hand of cricketer gets less hurt. Okay, and the similar question is there. A man gets less injured while falling on sand than concrete. Why? Please try this one on this question on your own. And here also the same reason is applicable. Okay, F is proportional to 1 upon T. Okay, when you suppose you are falling, okay, you are falling from certain height and you hit the ground. Okay, right when you hit the ground, that is known as initial momentum. Okay, for the impact. Okay, but after hitting the ground, after some time, you comes to rest. You have to stop. That is your final momentum. Okay, so how much time does it take you to come to rest? How much time does it take? That is known as time of impact. Now if you hit the concrete ground, then what happens? Immediately you come to rest. Let us suppose let's say 0.1 second time. Okay, 0.01 second time you come to rest in case of cement or concrete. Yes, but in case of sand, what happens? After you strike the sand, you sink in the sand. That means it takes certain time for you to come to speed, come to stop. And let's say it is 2 second time. Okay, so you can see clearly here, time of impact has been increased greatly by falling on sand, and that reduces force greatly. See, this is at least 20 times, isn't it? Time of impact has been increased by 20 times, means force will be decreased by 20 times, the same amount. Force will be decreased by 20 times, and the man does not get injured much more, or man gets less injured while falling on sand than on concrete. Okay, now our next question is to theoretically verify Newton's second law of motion. And you need to verify Newton's second law of motion. I already told you, you have to begin from definition of force. Okay, that is your second question. And third question, prove the relationship between F, A and M. Okay, in this case you need to start from Newton's second law of motion. Okay, these three questions are your today's assignment. I hope you will do it on time and submit by today evening. Tomorrow we'll continue on the lesson numerical on Newton's second law of motion and Newton's third law of motion. We'll cover these two lessons tomorrow, and our lesson will be completed, and I'll post you the exercise. Thank you, class.